Let's get into the big topic of open source, something that we actually say at Red Hat. We have a
This is so
We
awesome.
are an open culture that believes in the importance of
What is that process that a developer, or let's say
As the Kubernetes ecosystem really boomed,
Hello and welcome to this week's Ask an OpenShift Admin Office Hours live stream. I am your co-host, Andrew Sullivan, joined with me, as always, by Mr. Johnny Rickard. How are you today, sir?
I'm good, man. How are you?
I still have this thing going on, in case you can't tell by the way I sound. So apologies to our guests and to our audience if I end up going off camera in order to have a coughing fit at any point in time. Hopefully, I can avoid that. Got all the cough medicine, all the cold medicine in me, right? So if
Get
I
that
start
nice rasp going on.
yeah, well, it's from my wife, and my wife is a fitness instructor, right? So fitness people are crazy, in my opinion, right? They love early mornings. I don't understand why. Like, oh yeah, I want to get up at 4:30 in the morning in order to go work out. That seems great. So she's been, shall we say, not happy with me for coughing at night when she's got to get up early in the morning and all that. So it's I'm ready for this to be done. I think I said last week, I don't miss the last 2.5 years of the COVID isolation where we didn't get this stuff. Like, I don't remember having any sort of sinus congestion, sinus infection. But anyways,
Got spoiled.
yeah, well, yeah. Such as it is, right? There pluses and minuses. I feel like maybe I should stop my whining and accept my head cold in exchange for no global pandemic.
Priorities.
Anyways, yeah. So welcome everyone to this week. So we have an interesting episode. This is one that I personally am excited about because it's something that we've talked in bits and pieces about, right? We've talked about different areas. We've kind of, for lack of a better term, flirted with different aspects, but we haven't really gone in depth. And I think particularly after, was it last week or 2 weeks ago when we talked about like the descheduler and all that other stuff, I think that this is a great follow-on to that, because what we're talking about is pod autoscaling. And pod autoscaling is more than one thing, more than two things now, right? So it used to be, if we go back in the 4.6, 4.7 days, we had the horizontal pod autoscaler. And then we added the vertical pod autoscaler. And now there is so much more. Like I was, as we were planning this, as we sat down with everybody and walked through all these things, I was honestly surprised, and it was one of those today I learned moments of there's just a tremendous amount of functionality that's been added in here. So very happy to welcome all of our guests today. So where we'll talk about different aspects of pod autoscaling. So I'll say let's start off with introductions. So in my interface here, Chin, you're the first one up. So if you don't mind introducing yourself.
Hello, everyone online. I'm very excited to be online with Andrew and Johnny. I'm a staff research scientist from IBM Research, and my expertise is in pod autoscaling, especially vertical pod autoscaling.
Very cool. And I did not know until like just 3 minutes ago when we created your tag here that you were at IBM. So great to have you on.
Yeah, welcome.
Gaurav, if you don't mind.
Hi, my name is Gaurav Singh. I'm a product manager at OpenShift. I look after products like pod autoscaling, scheduler, descheduler, and anything which is kubelet related is what I look after. Thanks.
There's a lot of fun stuff in there, Gaurav. A lot of
That's right.
Kind of low level things. I think we talked about the secondary scheduler and stuff like that before. So
we can do a lot of these sessions. These all little things is world in itself, and it's very exciting, just like today's session.
Yeah, it's funny. Johnny will sometimes open up conversations with, like, "Hey nerds," or "What's up nerds?" And like,
What's up, nerds?
this is where I like nerd out, right? Is all in all these low level things. I feel bad, right? Now I've got manager in my title, and so it means that I have less time to be technical, which is a little disappointing. Let's see. Next is Naina.
Hey everyone, this is Naina Singh. I'm also product manager in OpenShift portfolio, specifically OpenShift serverless, which is based on upstream CNCF incubating project, Knative. And we are going to talk about the scaling options of it in today's session. Thank you, everyone.
Yeah. So it's funny because I think some people might wonder, oh, why is OpenShift serverless a topic here? And I think it's really important because serverless, what's the marketing tagline? It's like scale to zero or something like that. Most of the time, we think of it as, well, it's a developer thing. The developer writes their code, they put it into the serverless thing, right? Functions as a service and all that, and they kind of forget about it. But for us as administrators, right, there's pods underneath there, right? There's serverless is in name only. There's still a server there. There's still something that's executing all that app code. So we thought it was really important, and kudos to Gaurav for reminding us and inviting you, Naina.
Absolutely. I'm glad to be here.
Yeah. And then last, certainly not least, is Joel.
Hi. Apparently, I've got something going on too. I'm Joel Smith. I'm a software engineer on the Node team. We focus on everything to do with the OpenShift Node, but my focus especially is on pod autoscaling. And I wear a few hats. I'm also involved with upstream Kubernetes security. But anyway, I'm glad to be here today to talk about pod autoscaling. A lot of great stuff to cover.
Yeah, 100% agreed. And in case anybody's wondering who I do refer to when I say, like last but not least, who is least, it's always me. Always. I'm chief dumb guy, right? So welcome everybody. We really appreciate you joining us for the session. I'm looking forward to chatting with all of you. But we'll do our top of mind topics first. So we'll spend just a couple of minutes for anybody who is new to the stream, who maybe hasn't joined us in a while. Top of mind topics are things that Johnny and I have identified that may be important or relevant for you all to know since our last stream. So today, I think we've only got a couple of those. I will also point out that this is one of the office hours series of live streams with Red Hat live streaming, which means that at any point in time, feel free to ask questions here in chat. Whichever platform, whichever channel you happen to be watching us on, feel free to chat in there. It all gets aggregated up and sent out to all of the other channels, as well as in our lovely interface here. So ask questions about whatever it is that's on your minds. John and I and the guests today will do our best to answer those questions. If we don't have the answers, then we'll find them. So that's one of the great things about being in Red Hat and having access to all of the engineering and product management and everybody else is we can find those answers for you. Don't limit yourself to just today's topic, although I will say that we have a bunch of stuff to cover today, which is really exciting to me. So we may, if it's not related to today's topic, we may not just bring it up verbally, or we may condense those into one segment towards the end. But yeah, feel free to ask any and all of those questions. You can also reach out if you're not watching us live. You can reach out to Johnny and I anytime. So you can reach me via social media across Twitter and Reddit and all of the other places at Practical Andrew. You're also welcome to send me an email at any point in time, andrew.sullivan@redhat.com. And Johnny and I love getting emails, getting messages from folks. It's the reason why we do this is to interact with you all, with our audience. So don't ever hesitate to do that. And then I will throw Johnny under the bus. You can reach Johnny at jrocktx1 on all of the socials, as well as Johnny, Jonny, at redhat.com. I've known you for like 15 years, Johnny, and I still always have to remind myself there's no H in Johnny.
One of my good friends that I've known since I was in the Navy and so, just forever. She's like, Johnny, no age. So that's my name.
All right. Let's see. What have we got top of mind today, Johnny?
So the first one that I had was that Istio on September 28th last week they graduated from graduated to an incubating project within the CNCF umbrella. So, congratulations to all those people. That's a big movement. They got accepted as a project back in April, and so now the progression's going where now they're in the incubator state, and then eventually they're going to be like a full-on graduated project, and it's going to be awesome. So congrats to them. And then the other one is that they're on the Kubernetes blog site. I'm going to post the link here. There's a third-party security audit that it's essentially an audit where they're going out and just like, they're tracking all the security findings, and then they're declaring which ones need help on, which ones are fixed and stuff like that. So if you just want to keep up with it, here's the link. And actually let me post the link over here because I'm silly. So yeah, go ahead and check it out if you want. And then the other one is, this one's yours with the description of operators.
Yeah, so this is one that I pulled from the Kubernetes Slack channel. So for anybody who's interested, one of the communities that we have that Johnny and I interact with on a regular basis is the Kubernetes Slack team. So kubernetes.slack.com, I think, has an OpenShift users channel. So I'll paste a link directly in there. So on there, we see questions. We try and respond to questions as much as we can. But this morning, somebody asked, how do I get a description? How do I know what each one of the operators in the cluster does? I thought this was a good opportunity to remind us that there's a couple of different ways that we can do that. So I'm going to quickly share my screen here. And then I'm actually going to
Oh, Andrew, your audio cut out.
Right. Thank you. Because I turned I turned my square off instead of just turning my camera off. Let's see. Let's do this. Hopefully you can still hear me now.
Yep, we can.
Great. So if we go to the docs here, we're just going to go to OpenShift 4.11. There is, we do cluster operator. We have inside of here, there is a page. Well, I thought it came up in the first set of descriptions. Anyways, there's a page somewhere in here that talks about each one of the cluster operators. Why am I struggling to find this, Johnny? I should have found the page beforehand. Anyways, I will find that page at some point and I will post it into the chat. But there is a page in here that describes like each one of the cluster operators. So what do I mean when I say cluster operators? So if we go into, this is an OpenShift 4.11 cluster. I deployed it this morning, so 4.11.6. So if we go in here to cluster settings and we look at this cluster operators, each one of these is a cluster operator. These are the ones that are deployed by the cluster version operator. These are the ones that will become, today they're all mandatory, they're all required. In the future, there'll be some more flexibility there with composable OpenShift. But if you want to know what each one of these does, there's a couple of different ways to do that. The documentation obviously being probably the best one. You can also, from the command line, you can use the command ocadm release info -- commits. So what this is going to do is for the release in our cluster, it's going to list out all of the information about that release, including, and what the -- commits does. Let's see if I can make this a little bigger and keep it readable. Including, and the reason why I did the -- commits is because it adds in the GitHub repo for each one of our operators. So if I come over here to my cluster and I say, oh, I want to know what, I don't know, the image registry operator does. So I can search up here for image registry, probably easier for me to grep for it. So cluster image registry operator, right? I can take this GitHub URL, I can plug it in over here. Now I get the exact repo that's used by engineering, by Red Hat, in order to produce this operator. And you can see that there's a nice little description up here. There's some additional information about how to configure it. There's just a ton of stuff that's inside of here and accessible. I will have a slight warning of oftentimes what they'll have in this repo when we look at the docs and stuff like that will be above and beyond what's available in official OpenShift documentation. So sometimes you have to be careful about, making or doing unsupported modifications. But I also find that this is a great source. So to pick on the registry operator specifically, like we don't do a great job in the documentation of explaining all of these settings and all of the things that you can configure for the operator. But the GitHub repo has all of that. So anyways, that's kind of the most frequent way that I find the details on all these things. And I hope that's helpful.
Yeah, the one that I use that's similar is I'll use like OC get package manifest and then the operator name. And then within that, that'll have like so if you do like OpenShift GitOps operator, that'll show the description for the OpenShift GitOps. So if you want to look at the description for a non-cluster operator. I may have lied to you about the name of it. OpenShift GitOps, yeah, it's OpenShift-GitOps-operator.
Yeah. Oh, okay. So yeah, this would be for the non-cluster operators, right? Yep. Yeah, because these are all in the OpenShift marketplace. If I could get to the top here. So yeah, these are all the different catalogs. So these would be, correct me if I'm wrong, Johnny, if we go into Operator Hub, that's effectively all of these.
Yep. Exactly.
So if I wanted to know more about, I don't know, the GitOps operator, the one that you just told me to look at. And OpenShift Marketplace. Really? I don't know why it's not.
You pasted the cluster one, not the GitOps one.
Oh, did I? Oh, you're right, I did. That's what I get for using this slightly strange Shift GitOps operator. There we go. Thank you, Joel. There we go. So yeah, this is a great way to get all of that information. We can see the description here, as well as it gives us a lot of information about the images that are used. So we look up here. I always like to use this. The custom resource definitions, you can tell which CRDs it's going to create and which ones it manages. Another secret, at least for cluster version operators, cluster version operator managed operators. Oof. So you get CO. You can tell which objects belong to them by describing it. So OC describe CO image registry. Yes, I did mean describe. Thank you. Can't talk and type at the same time. So we have this related object stanza in here, and this tells you, oh, there's a, config object named cluster that is a part of the image registry group. Usually there's a namespace, right? So here's the namespace. So if I want to know where all of the objects it's managing are at, I can look in here and see this namespace. And now I can do this, OC get pod-n OpenShift image registry, and it shows me all of the pods associated with it, so on and so forth. So another way to kind of dig in and find out what's going on with those. All right, let's move on. Let's talk about pod autoscaling. Again, if you have any questions about any of the top of mind topics, really anything at mind, please don't hesitate to ask those here in chat. And then we'll walk through a couple of things. I think Gaurav, you were going to show some slides to kind of give us an overview of what's going on, and then we'll do some demos.
And real quick, I just wanted to acknowledge Borazum, for Borazum, whatever your name. I know I'm probably butchering that, and I'm sorry. Well, I see your question, and we'll get back to it. So Gaurav, go ahead, please. Sorry about that.
Okay, I'm sharing my screen. Can you see my screen, and can you hear me fine?
Yep, looks good.
Okay. So this is going to be a fun session where we're going to first talk about, what is pod autoscaling. As Andrew was saying, it is more than HPA, VPA, and one thing we are good at Red Hat is listening to our customers. And as Kubernetes or OpenShift matures, they are bringing new workloads to be run on top of OpenShift. And the new workload require new auto-scaling capabilities. right? So we've been listening to our customers, so we're adding new capabilities, and it's beyond HPA VPA. But we'll start from the basics, and what we'll do is we'll go through the slides, we talk about use cases, and Chen and Joel will help us to give some cool demo around it. Okay, so pod autoscaling. So I mean, what the latest version that we have released is 4.11 is GA. So I'm gonna take that as a baseline of this conversation, so you know what is there and what is coming as well. Okay, so good old HPA, horizontal pod autoscaling, right? That means scaling pod base horizontally, scaling out, scaling the number of pods. Basically, what have designed the whole conversation is around what is the application type it looks like, deployment, scaling parameter, and use cases, so that you understand where is fit within your use cases, right? So uh, what we have seen is HPA is mostly used by customer who wants to scale their stateless application, because you are scaling up, right? So and mostly people are using in production. I mean, HPA is so fundamental to Kubernetes that it's been there for a while, and it's been battle tested. So I've seen a lot of people are deploying this in production, and this today it scales on two parameters. One is a CPU and memory, right? Whenever there is a pressure is on CPU and memory, it scales out. And why people are using it in production is, let's say you're running a website, and your load increase on website, right? You want your website to be fully functional, fully effective, so you add new replicas of the pod so that it can better handle the load. Another thing is right? Out of memory. It's there from the starting of Kubernetes. What happens is, if a pod has two basic concepts, one is request and the limit. If anything goes beyond the limit, comes in, right? What is out of memory, it comes in and kills the pod. So basically, to for avoiding the pod to be killed, you need this HPA, so that you can keep adding new replicas. In that way, you're not hitting that roof limit.
So just to ask a couple of basic questions about horizontal pod autoscaling. So it triggers specifically off of CPU and or memory. So you set a threshold in the HPA configuration that says, if my pods exceed, say 80% CPU utilization, then create, 5 new instances or something like that.
That's true. And important concept to note here is there is a request and the limit. Limit is the roof. Request is what what is guaranteed to be available. Now, this HPA is based on request limit, right? Anything you can say, anything goes 50% or this percentage below this request limit, then add new replicas, so that the thing doesn't hit the roof and doesn't die.
Got it. And I see that you have stateless application at the top, right? So
yeah,
it works best with something like, an Apache or Nginx web server that can serialize or parallelize requests as opposed to like a MySQL database or something like that, where there's, which is not to say you couldn't get it to work, but out of the box, it probably won't work in that respect.
Yeah, I mean, it's, because it's holding a state, right? Any session, anything like that, you are replicating new replicas to the session that will not persist. Now you have to initiate the new sessions, things like that. That's why it's more stateless, where here's the pod, it has its own world. It's a micro segmentation of our entity, and I can scale out.
Got it. Thank you.
And now we talked about it. It was only scaling based on CPU and memory, but now we talked to a lot of customers, and new workload doesn't necessarily scale on CPU and memory. They need new, custom metrics. Maybe your application is very special, and you want to make sure the application scale when a parameter is being filled up. So that's why we are introducing a concept called custom metric autoscaler, and it is based on an upstream project called CADA. CADA has been widely used by industry. It is a is an incubating project in CNCF, and a lot of companies are already contributing to that. So we took that and prioritized in OpenShift. So basically, everything is same for CMA to work. Underneath, it use HPA, but now, how their design is, there is something called scaling objects, and this scaling object defines what when to scale, right? For example, there's a Kafka scalar object which tell when a consumer is there's backlog in the consumer, increase the producer, right? There is a scalar called Prometheus which can scrape out matrices, and you can define when this matrix goes beyond certain limit, you can scale, right? So now your world is now limited, right? You can build your own scalars. There's a up, and when you go to CADA, you can see a lot of scalars there, and you can build your own scalar. So now scaling is now is based on your imagination, how you want to scale. One more thing is, in car in during with CMA, you can scale to zero. So you can, maybe there is no traffic in there, so you don't need any replicas. It will scale to zero and then scale from there.
And Kita, which is the upstream project, right?
That's right.
So kita.sh, I believe, is the website for that. And if you look, there is just a tremendous number of scalars.
Yep.
I know it's in tech preview right now. When it goes GA, when it's fully supported, will we support all of those different scalars or only a subset?
So only a subset. Today we are looking at Prometheus as an initial out of the door scalar, and then and if customers is looking for more supportability, then definitely we'll look into it.
Okay. Yeah, and that's a really cool one to me. And we've talked about it a little bit here on the live stream before, of basically Prometheus is always there more or less in OpenShift, and you can point it to scrape various metrics, including metrics for your own application, right? If you turn on the user metrics feature. So effectively you can now configure it so that, hey, my application is processing, X number of requests. When it exceeds Y number of requests, deploy additional pods associated with it. So it's more than, or sort of CPU utilization doesn't necessarily matter. Memory utilization doesn't necessarily matter. But now we can do other things as well, including, I think, network utilization. I think that's one of the metrics that's collected on a pod basis, and, various other things. So that's, to me, that's really exciting and really cool.
Yeah, anything that you can feed into Prometheus, it can scrape and ask the HP underneath to scale, right? So it became more powerful in that sense.
Will it? So sort of a different kind of question, maybe. Can it also scale down based off of metrics? So what I have in mind here is, let's say, for example, because Prometheus has one of the things it's aware of is, for example, the number of nodes in the cluster. So let's say that we experience a failure, right? My node failed, and the scheduler will take a little bit of time. The control plane will take a little bit of time in order to fully recover from that. Can I proactively have something like custom metric autoscaler scale down? Oh, we went from 7 nodes to 6 nodes. I want to, cut my pod count by 5 in order to prevent other, maybe contention or something like that.
Yep. So I mean, it works in both ways, scale up and scale down. And then we're looking, I mean, there's another project I'm looking at, which is we're scaling based on scaling ingress pods based on number of worker nodes. So as worker nodes increases, it increase, and if worker nodes decreases, then the ingress pod will decrease. So it works in both ways.
Very cool. So I see Amit here has a question of how can we monitor auto scaling? For example, how many instances are spawned based off of CPU memory utilization throughout the day? Is there maybe Prometheus metrics that show you how many pods are associated with a deployment, so you can kind of get a chart and see that flow up and down?
So, Joel, do you know about that?
I don't know if that's a metric we scrape. You can certainly look at, the deployment status will show the number of replicas. I assume that's stored in Prometheus somewhere, but I don't know for sure.
Okay. Yeah, and I think that's a good thing to point out or highlight is that it is just it is relying on the deployment mechanism. So when we say the autoscaler, either the horizontal pod autoscaler or the custom metric autoscaler, when it says, hey, I need to deploy more instances or I need to reduce the number of instances, it's changing the number on the deployment object.
It can actually do any scalable object. So any object that has a scale sub-resource, HPA and VPA and custom metrics autoscaler can scale them. So it could be, a replica set or any object that considers itself scalable to the system can be scaled.
Which I guess to my comment before about stateful applications, I guess that would apply to stateful sets too, right?
Yep.
Great.
Okay. So another is our VPA, our good old vertical pod auto scaling, right? And this is basically what I've seen customers start using in more a stateful application. But in that too, right? Where I've seen more customer using is in test and dev. So what happens is a developer writes an application and then he literally throws over the wall to the production, right? And he will put some requirement like, hey, this is a memory and CPU requirement. And he put a lot of buffer in there. Now, an operation guy looks at the application and says, I don't know, what is the real usage of the CPU memory? I mean, what is the real size should I do for this part? So what they can do is they can run the VPA with actual load. Maybe you're doing A/B testing, things like that. Do it the actual load on that with the VPA, and VPA have a concept called recommender. So based on the load coming in, it can recommend, oh, you have 500 GB or MB of memory, you need 400 or 700. It can tell you that. And based on that thing, you can size your pod to either not undersized or not oversized. So exactly the same. So this is where I've seen it is very helpful and customers are using it today. And the VPA has two mode, right? Recommender mode and apply mode. So when you say just a recommender mode, it will recommends you things. And when you say apply mode, it will apply the setting. But there's a catch in there. When you apply the setting, the pod needs to evict and come back to adjust to the settings. So because of that, I've seen people say, okay, I'm running this production workload. I might not do this in production and run and test dep as a recommender mode. So a lot of people are doing that today.
So it has to have at least two instances, a scale of at least two for it to be non-disrupted when a vertical pod autoscaler action takes effect, right?
Right. So I mean, define in deployment side how many replicas should be there.
Okay. And can you use HPA and VPA together?
So no, there is they conflict with each other, and I will cover that later in the slide. I have a slide for that, where we are looking at into it.
Okay. Yeah, I think, what is that called?
Yeah.
Multi-dimensional
auto scaling.
There we go. Thank you.
Yeah.
Yeah, I think I've asked you that question before internally, and it was one of those like, if that happened, you could end up in these weird scenarios where it's trying to do both metrics at the same time, and you can encounter race conditions and strange stuff. Johnny, I haven't been paying a lot of attention to chat, but I see a lot of scrolling. Is there a...
Yeah, so there's some conversation, but there was one question from Ravi, and he was asking if we can define custom metric autoscaler and an OC project based off of memory and CPU, because they've had issues trying to do that within templates, like deployments and stuff like that. So is it possible to set it as a template in the project itself?
I am not sure. As in something I've tried to do.
I wouldn't think so, because you have to assign the autoscaler to a specific scale resource, right? So you can't, so putting it into a project template would mean that every time you do OC new project, it creates a new autoscale object. Mm-hmm. But if there's no pod or no deployments, no resource set, no stateful set for it to take action against, then it wouldn't work, I think.
Also, I was wondering, maybe know the use case for this, because you want to do it on CMA with the CPU and memory and not use the horizontal pod scaler that comes by default. Like, is there a specific use case that, Ravi, you have in mind?
Yeah, and just feel free to respond in chat there, Ravi.
Yep.
Yeah, I see down below, can we use it for VMIs, which I think is a virtual machine instance with OpenShift virtualization? Yeah. So I believe the upstream KubeVirt has like a virtual machine stateful set, but I don't believe that is supported with OpenShift virtualization. So the answer right now is no. Go ahead, Johnny.
Oh, yeah, sorry, I was just going to read Sanjay's question. So on the topic of auto-scaling, they were saying that one of the things that they've had issues is managing or tweaking how aggressive the autoscaler is when taking into account the average spin-up time for the deployment artifacts. He was asking, is OpenShift smart in this regard, or does all of that have to be tweaked manually? Like, do you have to tweak how aggressive OpenShift is in scaling things up and down, or is that something that's like OpenShift can just figure it out and do it itself?
So it does require you to set it up on a per workload basis. I mean, we do have defaults, but it's not like it's doing some kind of magic to figure out the right behavior for your workload. All it really has to go on is the metrics. So if you have, for example, a workload with a very long initialization time that's using a lot of CPU, you're probably going to have to tune the scale behavior to make sure that you don't get flapping or too much scale up because of your initialization.
Awesome, thank you.
Yeah, and one more thing, right? To adjust scaling based on your need, you need to understand behavior of your application and see how they are scaling. I mean, I've listened to customers where say, hey, when my application starts up, the CPU goes to the roof, and every time CPU goes to the roof, you're scaling automatically, right? And because my application is faulty and it's doing that behavior. So you need to understand your application first before understanding how any of the scaling features that you describing works best for you.
Yeah, that makes a ton of sense. Yeah, because you gotta account for the burst and everything too. Yeah.
Okay. Then, okay. So, alternative recommender for VPA. So what we have seen is there's a and we talked about a recommender before about how much CPU and memory it recommends based on the usage of the load of the application. Now, what we have seen is sometimes that is not enough, right? And customer wants to use new way of recommending. For example, right, a bank where the first day of every month the load increases on that application because everybody is checking their checking account, see if my salary is there or not, right? So now you want a way to the platform to understand that behavior and scale proactively so that you they can scale based on what a demand was there in past 6 months on first day of every month, and then scale down when it sees the demand that's right. So to understand that behavior, we have added this uh, alternative recommender where you can build your own recommendation engine, or will provide you new recommendation as an example, and you can do some AI ML or more creative stuff to scale, proactively scale your parts for that duration. So this is something cool thing that we are working on.
So I wonder if that might be the answer or contribute to the answer for Senjai. Apologies for butchering names. To your question of how much manual hand holding of the auto tuner or of the autoscaler needs to be done in order to have it account for things like spin up time and that. I don't know if it can do that, or if it's more like, when we see these three behaviors in conjunction, it means that there needs to be a scale up operation, and I can have that happen, something like that.
Yeah, we're going to talk a little bit more about that when we get to the section on the alternative recommenders.
Okay. Yeah, and Joel, I think you have a demo of that as well, or an alternative
recommender. Does.
Yeah. Okay. Or Chen,
Okay,
yes. Sorry.
I'll hand it over to Naina for Knative scaling.
Yeah, okay. Thank you, Gaurav. So in the midst of all these options that we talk about, there is another way to autoscale pods, right? And that is using Knative. It's a CNCF incubating project, and Knative is almost a must-have abstraction layer for your Kubernetes, as it elevates Kube for developers and ops, and it simplifies a lot of concerns. But today we will focus on automatic scaling or autoscaling via Knative Pod Scaler or KPA. So the incoming demand for the service is what drives the autoscaling in Knative, and this is provided by default. The added benefit of Knative service is the ability to scale back to 0 when there is no traffic. So because of this, what kind of deployments it works on? There are specific Knative deployments, which is called Knative service. These are stateless applications, and the networking protocols is HTTP or HTTPS. You can use it in any kind of environment, the production, test, dev, staging, it's available. And the scaling parameters are incoming HTTP bound traffic for autoscaling, and it has inbuilt scale to 0. Knative services come with the concurrent controls to let you control this behavior of how little, how much, and when you want autoscaling. You can do this with the concurrency and scale bounds knobs that are provided. There is some metric configuration as well, and it provides because we talked about custom metrics autoscaler and we talked about events. Knative also provides that, but the event handling is through the Knative eventing infrastructure that it comes with. Let me talk a little bit about the use cases. So Knative provide a low barrier of entry to Kubernetes for developers, as I was mentioning, and can be used in a variety of use cases. But in terms of autoscaling, I would say that it improves your application performance by adding replicas to handle load for better performance and capacity planning, and where you have a very little configuration to do on your part, right? And then applications only run when they need to, hence you get the maximum resource utilization. Additionally, you can use Knative for complex deployment strategies, and there is a tons more we can do. And maybe we can do a future session dedicated to Knative later on. But from autoscaling perspective, I just wanted to put it out there that this is also an option.
And Naina, just to kind of level set, so Knative is commonly referred to as serverless or functions as a service, right?
So Knative is the project that brings serverless to Kubernetes, right? And now we are working on providing this function, like the fast-like capabilities that you were just talking about. Mm-hmm. So yes, in other words, Knative for the vendor-neutral world and for Kubernetes world, Knative is what brings those serverless traits to Kubernetes. So that is you're correct. And our product in the OpenShift land is OpenShift Serverless, which is based on Knative.
Okay. And so just to clarify, there, on the surface here, there's a little bit of overlap, between what Kita and the custom metric autoscaler is or will be capable of in the near future versus what Knative scaling is doing, right? So we could point the custom metric autoscaler at Prometheus at a metric that's saying, how much HTTP or HTTPS traffic is coming in, if that's a metric that's collected. But this works more explicitly with that. I'll turn my camera back on now. So I'm just, do you have a, like when or how those things are different?
Right. So as you have noted that there are some similarities, and the bigger one I would say is that Kda can operate on the standard Kubernetes resources, right? Whereas the Knative would only operate on Knative service. If you have a stateless workload, it's very easy to turn it into Knative service. We do provide a utility. It is in tech preview in the OpenShift right now, where you can do like make my workload to Knative open serverless, and then it gives you the idea that whether you can convert it or not, right? So that's one thing. But coming back to the topic is that yes, existing apps must be converted. I see Kda and Knative as complementary because in the near future, Knative would also use Kda to scale up the eventing infrastructure that I was talking about. Mm-hmm. So if you are just looking from the scaling perspective, then yes, there is an overlap in there. However, Knative also provides additional capabilities like the concurrency controls that I was talking about. For example, I want to say when my load has come 75%, I want to increase my pods by 10% already, right? Those kind of things. There are reproducible deployments. So there's a concept of revisions, which is a snapshot of your code and the configuration that you have done. And you have an ability, and these are immutable. So whenever you make a change and you deploy it, there is another revision that comes in. So that gives you the traffic splitting capabilities. I want 10% of my load to go to my revision 1, and then which was saying hello from Knative, and I want another one to go to my new revision, which is saying hola from Knative, and I can do those. So that allows me to do that complex deployment strategies that I was talking about, right? Got it. And in addition to all that we do, there is an eventing infrastructure that manages data delivery, which I believe Kda does not manage data delivery. If you want, well, I don't know why, but if you want, you can use the HPA with the Knative deployed service, but then it's one or the other. Either you use the Knative autoscaler, KPA, or you are using HPA. However, there is a possibility. So if you want, for some reason that I do want my Knative services to scale up based on CPU and memory, you can do that by using HPA. So I believe those are and yes, and Knative also provides the rollbacks because of the revision functionality. It also provides out-of-the-box telemetry. So like Knative has extra, but if you have existing deployments and you want to just use Kda to do it, then that's where your use case is. I hope that makes sense.
It does, and I think it's important to point out that these are different, development styles, application deployment styles, and they both have auto scale capabilities that are available through OpenShift. Different metrics, different capabilities, and stuff like that, but they both apply, and that's why it's important to include, Naina and the serverless folks in this conversation. Because I admit that I a lot of times as an OpenShift administrator, I don't think about that aspect of serverless, right? It's just it's the devs doing whatever devs do, it's there, but it really has meaningful impact to us.
It does. And just to round the story, I'll say that because we are talking about difference between Knative and Kda, so how are they different? So the difference is how they detect incoming requests, right? So for example, Knative is very network oriented. It has a network router function, which is watching the request packets and target addresses. Kda, I believe, depends on other services like Apache Kafka and things like that. So it's just a different way of handling even the auto-scaling parts. But yes, Knative is beyond that. However, like you just mentioned, it happens that when we talk about OpenShift auto-scaling, we are not thinking about Knative, which provides by default. So I'm really glad that we are including this when we are talking about our pod autoscaling story in OpenShift.
Okay. So Gaurav, I don't know. I think there might be another slide or two, or do we want to go into and show some demos? I will leave. I'll put you behind the wheel. You're in control.
Yeah, thanks. Yeah, I mean, we have some cool demos where Joel and Chen can demo some of the capabilities. So I'll hand over to Joel, and he can talk more about it.
Great. So I'm going to share a terminal window showing some of the commands I'll be running. Okay, so we've already talked a lot about what the different autoscalers are for pod autoscaling. So let's just go through and run them and just give you a sense of how they work and what they look like. So let's start with HPA, and I have a workload inspired by a pet gerbil who likes to run on his wheel for 5 minutes and then rest for 5 minutes and then run on his wheel for 5 minutes and so on. So this workload will consume an entire CPU core spinning in a tight loop for 5 minutes. And then for the next 5 minutes, it will kind of run idle and only use about 10% of the core. So I've already got that up and running. Let's take a look at what an HPA object might look like if we wanted to use HPA to scale this gerbil workload. Oh,
Joel, as somebody who as a kid had both gerbils and hamsters, I love this example.
Okay, so I already created this object, but I'll show it here so we can talk about what it looks like. So the first thing you'll see in the spec is that it refers to an application, and this one in particular points to the deployment that we were looking at the top of the screen earlier. Well, this deployment up here, and so you can point that to any workload that's quote unquote scalable, which means it has a scale sub resource. And then we set limit parameters on there. We don't want to scale below 1, and we don't want to scale above 3 in this case. And then we next specify to HPA what metrics it should pay attention to and what the threshold is for when it should scale up or scale down. So in this case, we're looking at CPU. You could also use memory. And we'll talk about other options when we get to custom metrics, autoscaler, or CADA. And then there's also a section where you can control and fine-tune the scale behavior. That's something we alluded to earlier with a question about tuning it so that it doesn't scale too quickly or too slowly. So I've got just a simple one where we look at metrics over the past 30 seconds to determine whether we should scale up and whether we should scale down. All right, let's watch it. Let's watch it scale. So I'm going to.
And Joel, one thing I'd like to call out there that you have there, like where you have your max replicas, I think that's important to call out too, because when you set that, right, that keeps your cluster from running away, or keeps the autoscaler from running away and eating up all their cluster resources and essentially becoming that noisy neighbor that we're all afraid of.
I want to scale to infinity.
Yeah, exactly. Yeah, I had an example of this where we had deployed this a long time ago, and we didn't set that ceiling, and yeah, it just kept scaling up as it needed to, and it ended up taking everything.
So I'm displaying 3 different things here. I'm displaying the HPA object summary. That's this line here. Then also we're showing any running pods. And then finally the pod metrics. So we'll talk about this column here. This is kind of the crux of what the HPA is looking at. It wants to see that there's an average utilization of 500 millicores, or in other words, half a core per pod or less. And as long as it's in that range, it won't scale up. But if it goes over that range, it will start scaling up. So I think we're right now in the part where the gerbil is running on that wheel. And so we should see this number here rise, which you can see comes from this number right here. Okay, there, now it's up to a full core. And the number will move around depending on the timing of when the metrics get scraped. But eventually, after it's been 30 seconds or so of having the high utilization, HPA will see that it needs more resources and it will scale it up. So as we watch this, so we'll just keep an eye on that. And I just wanted to talk, oh wait, there, just as I say that, it starts scaling. Okay, so you can see it's created 2 more replicas, and it's starting those up, and those will start getting factored into the average utilization as well. Okay, so something that you may have noticed, there's a fair bit of delay when you're scaling based on CPU. This is due to a few factors. There's a delay in the pod metrics making their way through the metrics pipeline. And part of that is caused by scrape intervals of cAdvisor and Prometheus. So in the worst case, you could have to wait the full interval on both of those if you just missed, if they're just out of sync. Also, there's delay due to that dampening factor when you control the scale behavior. And then also we talked about earlier, if you have a pod that has an initialization process that takes many more or many fewer resources than the eventual steady state workload, then that can cause delayed or premature scaling as the initializing replicas have their metrics averaged in. So all that can cause, the case where it takes time to get to where it needs to be. Okay, so something else I wanted to mention. We've talked about scaling with CPU and with memory. There are not very many types of workloads that benefit from scaling horizontally based on pod memory usage. So be careful if you look at your workload and say, oh, I should just scale based on memory. There are workloads like that out there, and I'll talk about one example. But a lot of the time, if you scale based on memory, you might end up doing more harm than good. So one example, one that maybe would make sense, let's say you have a memory cache, and adding replicas increases the likelihood of a cache hit because you have more space to be caching whatever it is you're caching. And if the application is properly designed, then the replicas could even be removed over time as the system goes idle and items expire out of the cache. And so it uses less memory, and HPA could scale it back down. But often we'll see something where if you scale based on memory, your application will just scale up and never release memory. And so it just scales up and never goes back down. So if you want that behavior, you might as well just set the replicas to the max to begin with, because that's probably where you're going to end up eventually. So yeah, it's very workload dependent.
I don't know what you're talking about there, Joel. Applications always release their memory. Developers are always, garbage collection is priority number 1.
That's right. Well, even if you do release it to the garbage collection, a lot of times the application runtime itself has enough fragmentation that it can't release it back to the kernel, and that's the number that the kubelet is watching. So it's a pretty rare application that behaves properly so that it can be scaled using this metric. So that's the high watermark problem, we call it. You get up to some watermark of memory usage, and then even if you release the memory, the system thinks you still are holding on to all that memory because you haven't given it back to the kernel. So.
Yeah.
Okay, and then one thing I wanted to point out, and this is why this is a good lead-in to custom metrics autoscaler. Frequently, pod CPU usage is a poor indicator of how many replicas are needed. So like maybe there's a loose correlation, but there's not always a good correlation. It's very much workload dependent. Some workloads, it's a great indicator, but there's a lot where it's not so great. So, all right, well, you'll just have to take my word for it that eventually these pod metrics will go down and it will scale down because we don't have enough time to sit around and watch it. We want to move on to custom metrics autoscaler.
Gerbil's running on that wheel.
That's right. So they should be getting off the wheel any second, but we won't stay around to watch it. So let's just nuke that guy. Okay. Now, I'm going to delete the HPA as well.
Or Hope 9. Your comment there cracks me up. It can be fixed by requesting much more memory than the pod will use.
Yeah, maybe that defeats the point of autoscaling, but yeah, just over provision everything and everything will be fine. So. All right, I'm switching gears here to custom metrics autoscaler. Okay, so for this one, I've created, well, I've created a workload that is, sorry, Sorry, I'm still getting my bearings and I can't do two things at once. Okay.
Welcome.
Okay, there we go. All right. Yeah, okay. So as we talked about, Custom Metrics Autoscaler, which is our version of CADA, it's a wrapper around HPA. So it can fetch metrics from a variety of sources. Currently, we're just supporting Prometheus and then also CPU and memory. So it gets metrics from that source and then puts it into a format that HPA can understand. HPA is very simplistic. It only gets metrics from one place. So Custom Metrics Autoscaler is that place for custom metrics. HPA gets the metrics from it, and then it is kind of an aggregator of any metrics that you care about for your applications. All right, so the workload I created. So it's a contrived workload. It doesn't use very much CPU, but it does have a limit on the number of requests it can handle. It can only handle 10 requests per replica. And also each request takes 1 second. I call the workload decitasker instead of multitasker because it can't do more than 10 things at once. I guess I would be single tasker because I can only do one thing at once. Let's see. I should have a bunch of routes here, and one of them is running. Yeah, that guy right there. Oh, it's not running. All right, let's create it. I meant to leave this one running, so. And now what? Okay, we may have to skip this demo. I put the finishing touches on it in the wee hours of the morning, so maybe
that's okay. Yeah, it looks like it's a YAML formatting error, most likely. I won't say I'm familiar with those, but I'm very familiar with those.
Yeah. I'm not crying right now. You're crying.
Hey, if anybody can spot the typo, maybe we could fix it quickly, but deployment in version v1 cannot be handled as a deployment.
How about just trying v1?
Oh, I think I remember what's the matter. Okay, so I created this file, tried to create the deployment, and then ended up editing the file and the deployment and didn't make the same edits in both places. So I think I can fix it. All right. Oh, except I'm off camera editing that same file. Okay, let's do it on camera. All right. So the issue is the command. It's supposed to be an array of strings, not a string. So let's go like that and try again. Hey, hopefully demo saved. All right. So we should see now this workload running. And let's see if the curl command works. Oh, good. The curl command works. All right. We're back on track. Okay. So you can see that when I run the curl command, immediately prints beginning request. It sleeps for a second and then does request complete. And if I were to do 11 curl commands simultaneously, the first 10 would do that. And the 11th one would sit there waiting for its turn. And then once one of those first 10 is done, then the 11th one would run. So we're going to run Apache Bench against this application and see what happens. So I wonder if I wrote down the Apache Bench command that I need, or if I need to refigure it out.
Doing it live is always exciting.
Yeah, I've never done this particular demo before, so I'm learning on the fly which notes I didn't leave for myself. Okay, so it looks like we want -n for the number of requests. So -n, we'll do like 100 requests. Actually, let's just do 30 for now. Yeah. And then there's also a concurrency factor. I'm reading the man page change really quick. -C, who would have thought? Okay. So I'm going to try to do 30 requests at a time. I'm actually just going to set to 100 because later in the demo I'll be doing that. And then what did I do to make it angry? Oh, I guess I can't do that. I was trying to outsmart myself, but it didn't work. Okay, so it's trying to do all those requests. You'll notice that some of the requests completed in about a second. And then on average, they completed in about 2 seconds. And then on the high side, 3 seconds. That's because they were done by the application in batches of 10. All right, so what if I could just scale up based on the number of requests I'm seeing and then add more replicas so that I can handle more batches of 10 concurrently? Let's run that same Apache bench command, and we'll do it down in this window, out the extra A on the front. And I'm going to change this to concurrency 100, and I'm going to do it in batches of 1,000. All right, so this is going to start going, and it's going to take a long time because we've only got one replica handling that guy. Right. So let's take a look at what a scalar object would look like. Would be this guy here. I'll use highlight so that we get some color, some broken color. All right, so here what we have, just like in the HPA, we have a pointer to our workload. So it's a similar kind of thing. We can identify the workload based on labels. Also, I set limits on the minimum and maximum number of replicas. The interesting part now is when we get to the triggers. And Custom Metrics Autoscaler and Kata have a bunch of what we call scalars. A scalar is a piece of code that knows how to go scrape a metric from an external source. Could be any external source. So that's what the type field tells us, which scalar we should use. In this case, we want to use the Prometheus scalar. But there are lots of scalars. For example, there's one for Kafka that knows how to go and read information from Kafka so that it knows the size of the queue. And so this is one that we are currently planning to support, and we're deciding which other ones to support at GA, but they're all in the code. It's just a question of supportability from Red Hat.
Yeah.
Okay, so this one's Prometheus. Now, our Prometheus endpoint has credentials that it requires for you to scrape the metrics. And so here we have a reference to, it tells us how to get the secrets we need to get the bearer token so that we can talk to that endpoint. And that works for all the different scalars that require authentication. You can store those credentials in a secret and have them available to CMA.
Yeah, we showed how to get that bearer token on the stream when we did the Grafana stream.
Ah, nice. Yeah, and we have a great blog post that introduces Kata for OpenShift, Custom Metrics Autoscaler, and it goes through an example workload that this one is kind of patterned after. All right, it looks like Apache finished, so let's just start it again. In fact, I'm going to run that in a while loop. So we'll say while true. All right, so it's just going to run over and over and over again. Okay, then this is the endpoint that it queries. This is a local one on the cluster. This is for cluster-wide metrics, and what we're going to look at is a metric that our HA proxy exposes, the total number of responses sent by us back to clients. And so we select based on the namespace the app is running on and the name of the route. And then we look at that over the past 2 minutes and turn it into a per second rate. So what we're going to do is the threshold of 5 says that we want to have an average of 5 requests per second per replica. And so if the number is higher than that, we want to scale up so that we have more replicas taking up that load and thereby reducing the per replica average. So, all right, let's create this object. Right now, if I do get HPA, you can see here that this HPA was automatically created. It's created by Custom Metrics Autoscale. That's what the CADA prefix tells us. It's one that's managed by Custom Metrics Autoscaler. So we don't want to go in and edit this one because it's subject to being, any change we make is going to get reverted by Custom Metrics Autoscaler. So
oh, that's interesting. I didn't realize that it actually created an HPA.
Yeah. And I wonder if I run it again, if I'll have metrics yet. Let's check that. Oh yeah, we already have metrics, yay. Okay, so instead of saying unknown, now it says we have 3.5 requests per second. And over time, as the metrics flow through the pipeline, that should go up to 10 per second or thereabouts, because that's what our application is configured to handle. So as soon as it exceeds 5, in fact, maybe we'll just watch that. And hopefully it'll go up pretty quickly. Okay, so as that number rises, then that metric will get fed all the way through to HPA, which we'll see, aha, we're already at the point where it's too high. And so you can see the replicas column. We've already added an extra replica. So let's add some more commands here. So we can just do that. You can already see there's 3 of them. And my notes, I didn't leave myself the other command I wanted to run. What was it? Let me read it really quick. Let's see if I can figure it out. Okay, anyway, some other things I wanted to mention while this is scaling. So you can have more than one trigger. So you could, for example, you do a trigger based on CPU usage as well as this request per second metric. And then it'll do the calculation for both. It'll say, well, based on CPU, I think we ought to have 3 replicas. Based on request per second, I think we ought to have 5. And then it'll just use the higher of the 2 for scaling, for both for up and for down. So it'll always run both calculations and then just scale to the higher of the 2 numbers, if that makes sense. And you can add more than 2 if you have several metrics that you want to use to make sure you have plenty of capacity for whatever you're trying to do. And I think we've already covered everything else in my notes, except for this last thing. I just want to reiterate that where this is in tech preview right now, we really want to hear from our customers. So we would love it if you would try it out and tell us about your experiences. And we have ideas in mind for improvements, but bottom line is we want to prioritize the things that are most important to our customers. So please let us know what you think of it.
Yeah, and we just posted a link to the blog for Custom Metrics Autoscaler into the chat. And I think that there's contact method there. So anybody who does try it out, if you have feedback, if there's anything that you want to give back to the team, you can also reach out to Johnny and I, of course, and we'll make sure that Gaurav and Joel get that.
Okay, so I just nuked that deployment. We'll move on to VPA. Right. So I think I have like a little window that shows, but I have to do like watch dash color. Yeah, there we go. Now it'll interpret the bold properly. All right. So for VPA, we're gonna, instead of using a gerbil, we're gonna use a hamster. Those hamsters, they like to eat, and maybe they can get a little bigger. So we might need to size him up or size up his cage. All right. So let's take a look at this workload. It's very similar to the one we used for the gerbil. Okay, so we have a deployment here, and all it's doing is it's spinning in a tight loop for half a second and then sleeping for half a second. So we should get about half a core of CPU usage, but look at how much we're requesting. We're only requesting 1/10 of a core. So right off the bat, we can see that the requests don't match what the pod is actually going to use. Now, most of the time, you as a developer or you as a cluster admin, you can't guess with perfect precision what kind of resources your workload is going to use. So how do you take advantage of all the resources you have and make sure that you right size all your loads so that they can get packed in properly and make good use of all of your resources? It's hard to do. So that's where VPA comes in. It's a set of controllers that monitor your workloads. So Gaurav already talked about the recommender. The recommender is going to watch your workload's resource metrics over time, and it's going to use that information to make a recommendation. And Chen's going to talk about much smarter recommenders that maybe know a little bit more about what type of workload you have and can make a better prediction. But the default recommender, it just looks at the last n minutes and uses a kind of a histogram of your usage to predict what would be a good amount of resource request to have on your workload. Okay, let's create this project. And apparently I'm not logged in. Let's try that again. Hey, all right. Running at the wrong cluster. Okay, so I've just created that deployment that we looked at. So at this point, the pod will start, and over time, we should see up here, oh, there's 2 pods, right? There's 2 replicas. So they're both running, and you can see here that they request, that's that request value we have of 1/10 of a core. And eventually, the metric should flow through the pipeline, and we'll see how much it's actually using. And once it levels out, we should see it using about half a core. Okay.
I love your very simple command there to consume CPU of just using the timeout command with a yes.
Yes. Yeah, all yes does is print out yes an infinite number of times. It'll just keep printing yes till you kill it. So you just pipe that to dev null and you are using CPU.
Yeah. But Babuni asks, is it required to install a custom metrics autoscaler for this activity? So for this one specifically, I don't think so. But
I did skip a point. So HPA comes with every OpenShift cluster. It's one of the controllers that's just there. For VPA and custom metrics autoscaler, you have to install them through Operator Hub. So you just go in there, and if you want VPA, you just search for vertical pod, and you'll find it there, and you can install it. It has installation instructions, but it's fairly straightforward. Same thing with custom metrics autoscaler. You just search in there. And if you search for CADA, you'll find 2. You'll find the Red Hat one and the community supported one. We've had a community supported one for a while, but you'll want the Red Hat one now because that's the one that we're devoting our resources to going forward. And that's the one where you can get Red Hat support once we go GA.
Yeah, and it probably also important to point out, if it's not obvious, the metrics service is also a dependency. So if something were to happen to the metrics service for whatever reason, the node fails or the endpoint goes down, then it wouldn't be able to get the information it needs to make those scaling decisions.
Yes, and those, so in the case of HPA and VPA, the only metrics they use are CPU and memory. Sorry, I'm talking about vanilla HPA here, not with CADA. So that one has HA capabilities because it's just using the cluster's Prometheus to store those metrics, but it's quite a long pipeline. It has to go from C-Advisor in the kubelet to the kubelet's metrics endpoint to the metrics adapter and into Prometheus. So there's quite a lot of parts in there, and they all have to work for this dance to go.
Yeah, somebody was asking in chat earlier about, why OpenShift instead of other Kubernetes. And I think that's one of those reasons, right? Red Hat with OpenShift, we package all of these things up together, and we ship them as an opinionated OpenShift offering that out of the box can do things like HPA, VPA, all of this stuff, because there's a metric service that is automatically collecting information and making it available to those.
Yeah, absolutely. Okay, so the compared to the HPA object, the VPA object is very simple. You just pointed out a workload. Now it has other fields that you can configure as well, like limits and so forth. But in this case, we're just pointing it at the deployment and letting it go. So immediately what it's going to do is, oh no, why is this not working? Hamster-VPA. Oh, because I'm in the wrong namespace. And hamster. Okay, now it's going to be happier. All right, so look up here, this top section. That's pulling out only one field from the status of the VPA object. That is its recommendation. And right now it doesn't have a recommendation because the VPA just barely got told to watch this workload. But now it's watching it, and it's going to start fetching these metrics. And what metrics is it fetching? It's looking at the CPU used for these two pods. And so it's going to start seeing, hey, these are consuming, around half a core, depending on the timing of the metrics. So eventually it's going to make a recommendation. It's going to say, I want to give at least as much as it's using, plus a little extra headroom. So we might expect it to see, I don't know, 800 or 900 millicores. But we'll wait for that to show up. Okay, there it showed up with 716 millicores is its recommendation based on watching it for all of 30 seconds. And so now that it notices that the current request the pods are configured for, 100 millicores, is way off of that 716 that it thinks it ought to have. And so we should start seeing that the system will run what's called the updater. The updater wants to bring the pod's resource requests in line with the recommendation if they're way out. And so it'll look at this pod and say, oh, it's way too low. It's going to evict that pod, and then a new pod will get created. Now, how do we update this value 716 into that pod? We don't edit the deployment or anything like that. When the pod is created, there is a webhook that runs, and it edits the pod on the fly during creation process. And it will patch in the new value. You can see here's the new pod that's coming up. So it's going to bring up the new one first and then take down the old one. But this is one of the new replacement pods. So it patched in that 716 number over the top of the 100 millicores number and started that pod up. Now that that one's come up, it will remove one of the others so that we're back down to 2 replicas. And then it'll do the same thing for the other one.
So that's interesting that it uses the webhook instead of updating the deployment, because I think particularly, if you're using something like, GitOps or one of those to manage your objects, you're not actually changing the object that's being created in the cluster or anything like that.
Yes. So you have to leave that webhook service running all the time if you want the benefits of a VPA being able to right size your pods. And oh yeah, you can see it's changed its recommendation a little bit, but the 716 one is close enough to the 671 that we wouldn't expect this pod to get restarted. So it's replacing that one now. And there's a future feature that Gaurav alluded to that we're working on right now. It's an active project upstream, and I know Chen has put in quite a bit of work helping with it to expand the testing on it. And so this is the feature is called in-place update. And traditionally, pods once created are immutable, at least most of the fields, especially resource request field. This feature will allow us to edit a pod after it's been created. So rather than evict a pod and replace it, we'll be able to edit an existing pod, and the scheduler will say, we'll make sure that we have enough space on the node, and it'll do everything that it needs to do, and then it'll update those numbers on the running pod on the kubelet if it can be done. And so if you have an application that could benefit from not having to restart to get the new numbers, then that feature will be very interesting to you. And in the case of an application that has only, for example, one replica, today we don't update that manually. You have to restart it yourself if you want the new ones. But in the future, you would be able to turn on this feature and it would update that single running replica of your database or whatever it is that you can't be restarting to give it the new numbers as it gets them.
That I'm sitting here having my mind boggled by the complexity that's associated with that, of doing the in-place update, like you said, because of the scheduler and everything else, right? Most of us, most folks know I'm an old school virtualization administrator, right? We think, oh, just go in and change the memory or change the CPU, and it's a hot add, hot remove scenario. But the way that Kubernetes and the scheduler works, there's a lot of complexity there. So kudos to you, Chen, and the team for tackling that. That's a non-insignificant amount of work, I can only imagine.
Yeah, it is a huge undertaking, and that's I don't know if Garo is frowning right now, but he's been on us for a long time to hurry up and get that done. The customers want it today. So, all right, that's all I have for demo. But this is a good lead in for Chen. We were just talking about VPA and the standard recommender. So, yeah,
that was awesome. Thank you, Joel. And Johnny disappeared from camera for the moment. Very nice job on the recovery. I always like to poke Johnny because usually Johnny will have demo issues sometimes.
Oh, most times.
Thank you, Joe, very much. So, basically, today I'm going to demo the alternative recommender support for the default VPA. So since OpenShift 4.11, you are able to replace the default recommender with any algorithms you want to implement, either proactively or reactively. So back to the questions you just asked, whether we can do proactive predictions and also resizing ahead of time. Yes, you can. So as long as you know when to scale up for your pods, and then you can write your own algorithms, like for example, to scale up every Sunday, or to scale up on 30th every month. So I'm going to show here, you can see we are already in an OpenShift clusters, and we have the default VPA operator already installed. So how we configure to use a custom recommender. And as Joe showed, that we have something, we need to define something called VPA. So for example, here we have a workload here, and we want to create a deployment with 2 replicas that runs periodic spec for every 10 minutes, starting right from the whole of 10 minutes. So if it's 12:30 now, it starts specking for like 5 minutes, and then it goes back to idle. And in order to use the VPA, we need to define the vertical pod autoscaler CR with like how the minimum allowed, maximum allowed CPU and memory, and what type of resources you are control. And then to this, so this one we are using the default recommender, so we don't need to specify anything. And just for comparison purpose, so we go ahead and create this workload and its VPA.
So this would be expected to have behavior very similar, more or less in line with what Joel just showed.
Yes, exactly. And then let's take a look at another one. Which I here specify exactly the same deployment, the same image, just with the prefix of Pando, because that's the name I gave to my recommender. And the only thing you need is on the spec of VPA, you specify your own recommender name. And then we go ahead and create this one as well. So now we would have two workloads running exactly the same thing. And then, okay, the Pandu one is up, is bringing up, and then we can take a look at those two VPAs. So apparently the default recommender is still working. And then while it's bringing up the default one, let's take a look. We have by the way, we have a blog post on how to enable a customized VPA recommender. And then our customized VPA recommender is open source here. So what it does is it implemented a bunch of different machine learning algorithms like linear regression, the KNN prediction, and then and a bunch of others like we have a full list here. Let's go. Like naive Bayesian, etc. And then you can actually choose different algorithms for different types of behaviors. And then it doesn't only take a look at, for example, 5 minutes of resource usage data the default recommender is using. It can expand to any longer windows like 1 hour or 24 hours to understand your resource usage behaviors. So for example, it can capture whether you have periodic spikes every day at 12, or whether you have a trending behavior, which is spiking, adding up the memory every hour a little bit. So it can identify those different behaviors and then using machine learning to proactively see what would happen in next 5 minutes or in next 1 hour, and correspondingly give you a recommendation. So all the algorithms are still under testing, and we welcome everyone to test it with your own workload. So back to.
Excuse me, I'm looking at the code that you have there, the config map for that. Is there like the recommender config.yaml? Is there documentation for like the meta language that's there, or is that specific to the Pando recommender?
Yeah, that's specific to Pando recommender. And then, you're welcome to develop your own. For example, let me show. So this one is specific to Pando, but the development of recommender is pretty simple. So all you need is get your recommendations, select it, all the VPA object that specify your own recommender name. So you can give your recommender name, and then go ahead and patch the recommendations to the VPA object. And then the VPA updater and web automation controller will take over all the restarting and resizing stuff.
Got it. So I think a key takeaway here is this is almost certainly going to be done in conjunction with the application team. It's not something that we as administrators can do by ourselves, or I guess the app team could do it by themselves, but we probably want to work together with them to understand how it's going to scale with the custom recommender and how we can architect the cluster in order to accommodate that.
Yeah, so I think it's the recommendation algorithms really vary workload by workload. There is no universal standard. And then the default one works really well for those workload that have very stationary resource usage, meaning your average utilization and standard deviation of the utilization doesn't change much over time. But if you have some special behaviors, like periodic behaviors, or you have a trending behaviors up to a certain hour a day, then definitely you need to understand the workload better to have your own recommender. So what we can see is the default VPA already found out it's during the idling period and then give a recommendation of the 100 millicores. And this one doesn't really do anything because we haven't deployed our Pando recommender yet. So then we want to go ahead, deploy our Pando recommender.
So you touched on something interesting there, Chen, of we get asked, or at least Johnny and I get asked on a semi-regular basis of like, can I do predictive scaling of my application, even of the cluster itself? So it sounds like that it is possible to do that with the custom autoscaler or the custom recommender.
Exactly. So you can always develop something like predict the burst and then just scale up before the burst. So for our Pando recommender, you can also try Pando recommender with different configuration. For example, you can configure the forecasting side, meaning how long you can observe your history to understand the behavior. You can configure how ahead of time you want to foresee the resource usage. And then for different types of behaviors, we will have a detailed documentation later about those behaviors we are detecting, and then what particular machine learning technique you want to use. And we have like over 10 available machine learning prediction mechanisms implemented in Pando. So Pando could be a very simple starting point for your workload. And then if it doesn't work well, and then you can also go ahead, develop your own recommender. So the only thing Pando needs is trying to understand what is the default workload namespace you are managing. So here our VPs are created in default, so let's change it to default. And then it also needs the access to Prometheus metric, and you can just simply create a service account for your recommender deployment, and then grant the monitoring cluster monitoring view to that service account. And I already did that, so I will escape those steps. And then Prometheus URL. It's just a copy of the Prometheus URL of my cluster.
Yeah, that'll be the service endpoint.
Exactly. And then, excuse me a little bit, I will copy the token secretly.
And I see there's a couple of questions. We'll get to those in just a moment. So Frostmageddon, Benjamin Orzum. I think there was one from Amit as well. So we'll get to those just a minute.
Okay. So then go ahead, create this Pando recommender. So hopefully it's running under
maybe the wrong namespace.
Yeah.
You got you got the vertical spelled wrong. It's VER. You got INC
yeah.
backwards. Yeah, that's a standard Johnny mistake right there.
Thank you for spotting it. Okay, this one is running. Let's check the logs. Let's see. Oh, so my token is apparently wrong. Let me get the token fixed.
But I mean, that's a happy accident there too, right? Because now you kind of see the output of what it looks like when it's not good.
Mm-hmm.
Yeah. And while Chen is fixing the token, maybe I could answer Benjamin's question. So why is it that we would want to change the pod requests over time? And this all comes down to being able to fit as much as possible of workloads on our cluster. Imagine you have a cluster where pods are coming and going all the time. And so if you have a period where this app needs a lot of resources, followed by a long period where it doesn't, then you can kind of release that reservation back to the system. The scheduler can put some of those dynamic workloads, pack them in on your node. And then when it gets to the point where it's going to need more again, it can update its reservation and the scheduler can, reserve more space for your workload at the time when it needs it. So it's just all about packing as much stuff in as possible without oversubscribing. So making good usage of your resources. I hope that makes sense.
I think what you said there at the end is important, right? Which is the without oversubscribing, because the alternative is basically no limits and letting the pods Hunger Games each other. With things like the eviction and all of that, being able to hopefully they eventually land someplace where they get the resources that they need, but probably at the beginning they're going to be oversubscribed and there's going to be contention or potentially contention, and then you have this other delay where it has to go through eviction and rescheduling process. Frostmageddon, does the VPA protect from a pod being hijacked and using more resources when it's learning what the recommended CPU/mem usage is? So I don't think we can protect against memory leaks. Basically it looks at what resources the pod is using. If the application has an error issue problem that's resulting in a memory leak, it is what it is. But for the learning aspect, I would think, and we've seen this, we saw this during Joel's demo of the first recommendation was, 716 because for its look back window, it was higher. Maybe it was using CPU for, 18 out of 25 seconds. And then the next one was a little lower. Maybe it was using that 100% CPU for only 14 out of 25 seconds. So it'll, in theory, it would adjust over time to land at the right amount of resources. And that would depend on, the various configuration options, I would think. I feel like I'm talking for Joel here or Gaurav. So please don't hesitate to correct me if needed.
Yeah, so you can, the way to protect against a memory leak is with a pod limit. You can set a hard limit on your pods and then just have the VPA only, scale or set the request within that limit, and so it won't go above that. But yeah, if you have a memory leak in your application, the VPA is going to look at your application and say, oh, it needs more memory. And then 5 minutes later, it's going to say, oh, it needs more memory. It's just going to keep doing that until it either runs out of memory or until it bumps up against those limits. So yeah, it's not a Band-Aid for a broken application. But the idea is that it should be able to figure out how much memory you're using over time, depending on the application type.
Yeah, and Amit asks, when looking at the utilization percentage, for example, CPU utilization, does it calculate like 80% based off of the limit or based off of something else? So does there have to be a limit in place for it to be able to gauge?
It's based on the requests. So you must set pod, if you want to use the percentages, you must have pod resource requests set on your workload, or it can't use the percentage. You can also set an absolute target value if you prefer, and then you aren't required to set resource requests.
Got it. Well, that looks like a good output, Jen.
Yeah, sorry for the wrong token. Actually, it is actually doing the prediction now. It gets some data and then it tries, for example, it detects the behavior belonging to the ID we set 11. It selected the prediction algorithm as KNN, and then it does some predictions. Apparently, it's during the idling period. And then I don't know if we have enough history or time to wait until it recommends something birthday. So if we go back and see the VPAs, now actually Pando test is picking up by the Pando recommender. So that's all I want to show today.
Very cool. And I just realized that the CPU number is a float. Like you can specify all the way out to all those decimal points.
Oh yeah, we actually do a round for that when we specify to the 2 second digits, but not exactly as the prediction show here.
Mm-hmm.
I just want to brag about Andrew showing off his programmer side to use a float.
Hey, it's a stretch for me too. Let's not get carried away. Frostmageddon. So the VPA only works or only modifies requests. It doesn't change limits.
historically, that was the case. In the more recent versions, and I'd have to look up when this feature was added, it can now modify limits as well. Although a lot of folks don't like that. And so it's a feature you can turn on and off. It's on by default, I believe. It's on a per VPA object basis. So when you create a VPA object to monitor your workload, you can tell it, don't touch the limits, only work within the limits on the requests. Or you can leave it as is, and it will actually modify the limits if they're set on the workload.
So I'm gonna.
So I'm going to share my screen for rest of the presentation. Give me a second. Can you see it?
There we go.
All right. Okay. So thank you, Jen and Joel. How they were showing it feel like it's magic, right? You have something and it is scaling out and scaling up and scaling based on some AI model. It feels magic by itself. Now, what we are going to talk about is more futuristic thing, right? What we are working on from community or upstream point of view. One of the thing Chen has or Joel has already touched upon is in-place VPA, right? Now you are an admin, you're doing things in production, you're using VPA in production. You do not want your parts to evict and come back, right? You do not want your application to start and stop. So one thing that we are working on is in-place update of VPA, where your recommender recommends something, and it will, by admission webhooks, it will go and update the resources of the pod. So this is something that we are looking at, currently working on. Maybe from upstream point of view, looks like it might land in 126, but let's hope that it's a current branch for Kubernetes. Another thing that we are working on, and Andrew, you touched upon, is can we use HPA and VPA together, right? And it's been the question for a while. Now, we look at it, it looks like things might run into race condition where you have HPA doing one thing and VPA doing one thing, and it might goes into a infinite loop. So we look at the problem set and we think and we come up with like, hey, why not scale both, right? Maybe scale horizontally on CPU. On the same time, you do not want your application to be killed, so you are scaling out based on memory. Actually, Chen has a lot of experience and background, and in fact she's working some of the good researchers in this area. Maybe I will let Chen talk a little bit on this.
Yeah, sure. So we indeed try to use both HPA and VPA for the same type of workload in the cluster at the same time. So what would happen is because the existing VPA algorithms are based on resource usage. For example, it set a target 90th percentile usage as the default request. And then so it seems it's shrinking the pod all the time. And then at the same time, people usually use HPA for performance target. Like I want to achieve like all the requests coming in should be within 500 milliseconds. And then what happened is when the size of the pod is just 90th percentile and your performance goal is very tight, it will try to add more and more pods. You would end up with a lot of small pods, a large number of small pods for a particular workload, and then you don't have either resource efficiency or performance guarantee. So in this way, we have to control the scale out, scale in, and scale up, scale down in combination. Meaning we have to consider what is the optimal size and the number of replicas in order to meet a certain performance target. And that's why we come up with this design. So we want to design the multi-dimensional autoscaler in a way that the algorithms can do a combined control just similarly as VPA. And so later we can replace the algorithm with whatever algorithms we believe that is correct for a particular workload. So the algorithms we have explored these days include reinforcement learning, deep reinforcement learning, and then from initial test and a bunch of papers we published this year is working pretty well for a lot of workload. And then again, once the MPA prototype development is done, I think you will be free to plug in any of your algorithms as well, just like the VPA support on alternative recommender.
That's really cool. Now, Gaurav, we just have to. What was the other question I asked you about? Multi-stage scheduling. Being able to make decisions about rearranging workloads. Just one problem at a time. These are all easy things, right? It's just code.
Just code.
Just code.
But I mean, when you look at it, right? I mean, we initially started with a simple way of doing it, like VPA. Then we understood, hey, if what today is there is not addressing new workloads, so we put recommender in there. Then we figured out, hey, customer do not want it to be reboot on the production, so we added in place upgrade. So we keep listening to our customer and keep adding stuff. I mean, and as I've used the term magic, from customer point of view, it's all magic, right? It's all happening seamlessly, automatically. But underneath, as you were mentioning, it's the scheduler that needs to understand, the admission web hubs needs to understand, and the whole ecosystem needs to come together.
So Gaurav, quick question. Well, and I don't even know if you can answer this or not, but like, is there a plan to where, say you have a cluster that's performing or underperforming, like where it'll use especially if you're in like a multi-cluster topology, like you have ACM or whatever, is there a plan where it'll say, hey, look, this application can't perform in this cluster, but there are some resources over here where it'll dynamically start moving workloads to another cluster?
Oh, no,
actually,
some KCP level stuff right there.
So one of our colleague from Chen Group, he's working on a specialized scheduler which is called load aware scheduling, where it understands the load on the scheduler or on the cluster. So when pod comes in, it looks like, hey, I want to balance the cluster, so schedule the pod to another node. So there is one which is entry, right? So which is day one. There's another thing called descheduler, which is also a day two, where it can understand that, hey, this pod or this node is been hammering up. I'll reschedule this pod to another node. So it could be combination of one or two.
Yeah, that's awesome.
Yeah, that'll be really interesting to see.
Yeah,
KCP. I'm again, my mind is boggling. That happens a lot. So with KCP, where we're kind of abstracting clusters away into a project, KCP terminology project, not OpenShift terminology project. That there's a lot of potential there. There's just some really, really cool stuff that's coming down the pipe. I'm always excited. It's OpenShift. It's really fortunate, serendipitous when you love your job and love the products you get to work on, right?
Indeed. Yeah.
So I think we did have one question about the autoscaler that went unanswered, and then we also had another question that somebody asked way back up at the beginning, which was around the Red Hat storage announcements. So, Johnny, I think you flagged the first one, the one about scaling based on cost management.
Yeah, that was from Dwayne. He was just asking if we can base scale off of cost management.
So that, for example, if you I don't know, can you give me an example on that?
Yeah. So say you've defined a target for your cost management, right? Like I set a budget, dollar wise. Is there a way to use that target amount to scale down or scale up, right? Where it's like, hey, scale up to meet that target, or scale it down to keep it within the target.
Yeah, Chen, anything happening in research on that side?
Yeah, definitely. But there's you can develop your own recommender, right? So monitoring your cost all the time, and then decide your size shouldn't exceed an upper bound. And then there's a easier way to do that, which is just changing the VPA upper bound definition, right? So if your cost budget, you are reaching out to the cost budget, then you can specify you never want to scale up beyond one CPU, for example.
Gotcha.
Yeah,
Okay.
I was thinking that maybe it would be possible, like let's say there's an API for console.redhat.com where you can extract those cost management metrics and basically point, the custom metric autoscaler at that, and whatever data is coming out of there, that might work.
That'd be cool.
Yeah. I mean, with the with the alternative recommender, with with CMA scaling objects, you can really build your own world and have it scale based on whatever your need is.
Yeah, just some might be a little more work than others.
Yeah.
So we wanted to, and somebody asked earlier, my apologies, I don't remember who. There's been a lot of chat, and thank you everybody for all of the chat. We do appreciate it. So some folks asked about the announcements earlier this week around Red Hat storage, and in particular ODF, and the merging with IBM storage. So there's a couple of press releases that went out, both one on the Red Hat website as well as one on the IBM site. So the key thing to know here is that the Red Hat storage team, which includes Ceph and all of that, is moving into the IBM storage team. So from a technology perspective, this is really a great thing. Red Hat and Red Hat Ceph storage has really been focused, and most of the improvements, engineering effort, everything have gone into kind of two key focus areas: ODF, OpenShift Data Foundations, as well as Ceph with OpenStack, Red Hat Ceph storage with OpenStack. So I think at the Ceph level, at the low storage level, this gives them a tremendous opportunity to get a lot more attention, focus, energy, and investment at that level. So at the ODF level, because we're OpenShift administrators here, at the ODF level, it's not going to change anything. So ODF is still going to be a part of OpenShift Platform Plus. You'll still be able to get ODF from Red Hat. You'll still get support for ODF from Red Hat, right? All of those other things. So nothing changes there in that respect. So I will say having some of those folks on my team, having talked with some of those folks because we're adjacent to them, both the engineering, product management, et cetera, I think the vast majority of them are also really excited about it and what it means and the possibilities. So if you have any questions, feel free to reach out to Johnny or I. Also, I would encourage you to reach out to your account team. So your account team will have a lot more information about precisely what it might mean for entitlements with folks who are using standalone Red Hat Ceph storage. But yeah, don't hesitate to reach out if you have questions. With that, thank you so much. Chen, Gaurav, Joel, Naina, who had to drop. We really appreciate you coming on. This has been absolutely fascinating. I used to think that I understood, had a good grasp of what was happening behind the scenes, and I realized that no, like most things, I had what do they call it? The Dunning-Kruger effect. Right, where you start out, and then you have this trough of disillusionment. I'm in the trough of disillusionment right now. So this has been great, and I feel like I am both well prepared as well as more terrified than I was before. So you all are welcome back anytime that you would like, and we would love to dig into more details. For our audience, thank you. We really appreciate you being here with us as well. Chat has been phenomenal. We love all the questions. As Johnny and I say, you all are why we're here. The questions, the stuff that you all are asking us is why we're here. So really happy that we were able to answer those. For anybody not watching us live, if you have anything that comes up, or even for folks who are watching us live, if you have anything that comes up after the stream ends, feel free to reach out to us. So again, you can reach out to, You can reach out to me on social media at Practical Andrew, or email andrew.sullivan@redhat.com. I try my best to get to those as soon as I can, but sometimes I do lag behind. So my apologies if it takes a day or two to reach you. And John, you can reach out jrocktx1 or johnny@redhat.com. So thank you again to our guests. Greatly appreciate you coming. I feel like I should send you all stickers or something to say thank you for this phenomenal session. And then to our audience, again, thank you very much. Johnny, wait, what do we have coming up next week? Next week is composable OpenShift, I think.
I think so, yeah.
And we're working on sessions with the GitOps folks. So
Yep.
I requested a GitOps for Dummies session because I'm a dummy and I need help with GitOps. And then we've are also still talking with the logging folks. So hopefully we can get some more information about Vector and Loki and what all that means. So if you aren't subscribed on whatever platform you're on, go ahead and click the subscribe button. You can also go to red.ht/livestream. So I'll put that into as soon as I can type and talk at the same time.
Yeah, and we also talked to Dean from VMware too, and so he's looking forward to coming back. So we'll have another session with Dean, and that's gonna be a good one. And logging.
Yep. So we've got lots of content out through the end of the year. So yeah, for everybody, thank you, Johnny. I will leave you with last words.
Just thanks again, team. We really appreciate it. It's awesome. Like the last couple of weeks, we've done some stuff with like the descheduler and secondary scheduler, and so just the more we dig in, I think the more Andrew and I are realizing like we don't know jack. So, but no, thanks for coming out. This was really great, and thanks for the demos. So we'll see you guys next week.
Thank you.
Thank you.